So now we have a setup of the photoelectric effect as we drew in the notes. And so we have our light source here. We can change the amount of light that is being emitted. And we could also change the intensity. And so what we're going to do is we're going to start off in the IR. And this is how bright that is. And so there's two ways of showing it. We can change this to show as just light, or we can show it as photons. I like the photons because the intensity, as the intensity goes down, the number of photons. Now, this experiment, people didn't know. So what I'm going to do is this is what we thought was happening, was we just had light. We didn't know this thing was a photon existed yet. And so what they expected was, even at the expectation was, even at these low energy wavelengths, or these high frequencies, again, wavelength, low energy for a wavelength is a long wavelength or a short, or a long wavelength, or a frequency that is very long as well. So what we'll see is that the intensity, no matter how intense we make this, no electrons are ejected. And this was weird. They thought that, well, it would add up, that if I had, even if it was low energy, if I had enough of it, that electrons would be ejected. Okay, so then if you just start toggling the energy of the waves up and up and up, keeping the intensity high, we eventually see at some point, so right around 535, let's bring it down, let's see, 541, that at some point electrons start being ejected. Now I went to 541 and then electrons stop. So if I go to 535, we start seeing them being ejected. And so there's some threshold at which you have to have a specific energy of electromagnetic radiation or above to eject electrons. And so if we reduce the intensity down, then what changes is the number of electrons being ejected. So we'll make this like 40. And you can see that that there's less electrons being ejected per unit time. If I increase it all the way up, you can see that those electrons start going up again. And then we can observe that as we increase the energy, what happens to the ejected electrons? Woo! Look how fast they are going. They are blowing those other electrons out of the water. So what happens is the additional energy that is being supplied by the light is going towards electromagnetic radiation. So you have a threshold energy, an energy barrier you have to overcome. And any additional energy goes towards the electron's kinetic energy moving across this potential gradient where we have the positive plate here. So we can look at a couple things. We can look at the electron energy and light frequency, and we can see that we can go down, and if we go up, we can see this linear relationship. So as we have higher energy light, the energy of the photon goes up, and if we go lower energy light, we go back down. Okay, and there's at some point where we have a frequency that nothing happens. So it doesn't go through zero, which means that we can't have electrons being ejected until we reach right around here in this frequency. Again, they don't have a wavelength, but and so you can look at, you could also look at current, you could look at voltage. That's not, we don't really need to care about that. And show the other thing I want to show you is that different metals. Okay, so we know that for sodium it was around 540, or sorry, 530 something. But let's go to zinc. Now that's not good enough. So if we're going to go, let's see where that frequency threshold is for zinc. It's way down in the UV. There it is. So zinc has a much higher energy threshold before we see an ejection of electrons, and you can see that here, that in this bottom graph, that as we increase, now you can see it starting off further down. If we go from zinc to copper, where's copper? It's even farther down on this graph. How about platinum? Platinum, oh, that is way down there. So it's like 1.5. How about calcium? Calcium is back to in this range. Calcium and sodium are very similar. And what is question mark? I don't know. somewhere in between. Anyway, so you can see that different metals have unique thresholds, and that as we increase the intensity, the kinetic energy increases in a linear fashion. So these are the observations of the photoelectric effect that you can see in the simulation, and we will now talk about what resulting theories came out of that and summarize what we just saw.